Hello, everyone. Thank you for joining us for today's webinar. I'm Carr McDonald, the Director of Education for UXPA International, and I'm joined here today by Ovetta Sampson. She's Design Lead and Design Researcher for IDEO. Today, she's going to talk about common AI and ethics challenges and how to solve for them. And before we jump right in, there's a few things that we need to note. So all of the audio is muted, with the exception of our speaker, Ovetta. So if you have any questions, we do have a questions panel to the right hand of the control panel. So please drop your questions in that window. Also, this webinar is recorded and it will be made available at the conclusion of this talk. Lastly, please register for our upcoming UXPA International Conference. Registration is still open, and please tune in to Ovetta's short course, which is coming up in May. So on May 3rd, 10th, and 17th, Ovetta will be presenting a short course for those 3 days on mastering design anthropology for making better AI decisions. Without further ado, I am going to introduce Ovetta and allow her to get our webinar started for today. Ovetta?
Thanks, Carmen. Thanks, Carmen. Hello?
All right. Yep.
Okay, can you see my screen? Yep.
1 second.
Yep. Okay, show my screen.
Yes, we can see the screen, and go ahead. Thank you.
All right, thank you. Well, hello, and welcome to the UXPA free webinar, Common AI Ethics Challenges and How to Solve Them. I'm Ovetta Sampson, your host, and I hope you're in the right place. I'm so glad that you're all here. This is amazing. I'll try to keep this informational yet fun. We have a packed hour with a bit of time for Q&A, so I have a lot of stuff today, so I'm going to try to fly through it. As Carr mentioned, this will be recorded, and so you'll be able to kind of like go back and go over things. So today's overview, we have 60 minutes to cover a vast landscape. I'll start with a bit about who I am, where I work, and what I do, just so you can understand where I'm coming from today, and then we'll get into a basic explanation of today's current state of AI. After that, we'll talk about the intersection of AI and user experience, which doesn't get a lot of talk these days, and I'm excited to kind of like share some things with you in that regard. And then that will lead us to common ethical challenges that we who design for AI see when we're designing systems, and that occur when designing AI products and services. And lastly, I'll go through how to tackle some of those ethical pitfalls by sharing some ethical AI design principles created by IDEO and some other really great companies to help guide you while designing and developing AI. All right, let's go. Well, I have to do the plug about my company here. First off, a quick history of IDEO. IDEO was founded in Palo Alto in Silicon Valley in 1991. We're a global company. We have offices in 9 cities, including Chicago, where I'm speaking from today. And we have a multidisciplinary approach to solving design challenges. We have about 700 creative designers, one of which is me, and we work together in cross-disciplinary dedicated groups in IDEO design teams to create a culture rich in ideas, experience, and empathy that uniquely enables us to deliver innovative experiences for our clients. We, of course, practice design thinking, the design thinking process which combines what people need, desirability, with what makes sense for our client's business, viability, and what's technically possible, feasibility. Truly innovative solutions require a balance of desirability, feasibility, and viability. But our work always starts with people, and that's user research, which is what I do here. Just a little bit about Chicago, and the only reason why I'm talking about this is because Chicago is kind of like our brain of our AI and intelligent systems design. Coincidentally, I started working at IDEO the same year that in 2016 when IDEO Chicago acquired Datascope, a Chicago-based data science firm. I've been working for nearly 3 years with our newest design discipline, data science, to form, craft, and create what we call human-centered augmented intelligent products and services, what we like to call human-centered artificial intelligence design. Okay, commercials are out of the way. Let's start this puppy. So, in the summer of 1955, John McCarthy, a cognitive and computer scientist at Dartmouth, along with Marvin Minsky from Harvard, Nathaniel Rochester of IBM, and Claude Shannon of Bell Labs, wrote a 2-page proposal for a 2-month, 10-man summer research study to answer a simple question. In a single sentence, they wrote, "The problem is, how can I make a machine which will exhibit originality in its solution of problems?" These 10 men wanted to gather for the express purpose of making a machine behave in ways that would be called intelligent, if a human were so behaving. You could call it the summer that the study of artificial intelligence was born. Some people do. Since that AI summer study group was hatched, AI has made quite some leaps in both problem solving and behaving intelligently. Still, there's so much mystery and hype surrounding artificial intelligence today, it's tough to understand just how far advanced we have become with machines learning and doing. So that video I just showed you may look a little goofy, but it's Google's DeepMind released a series of videos showcasing a funny-looking stick figure traversing through a bunch of simulated obstacle courses. What followed were various hilarious moments of these videos on Reddit, Twitter, and Facebook, and the like, about the awkward motor skills of Google's AI-created agents. And they were pretty hilarious, as we just saw. But they were also pretty legendary and a leap for an AI. Because while teaching AI agents how to walk isn't new, in fact, has been done before, what was unique about this paper and these videos is that the agents actually learned to walk, jump, somersault, and various physical movements all by themselves. These agents were not programmed to do so, and this was a mind-blowing leap in AI. Machines have learned to make decisions, do repetitive human tasks like write and deploy emails, answer phones, even take food orders and deliver food. But though they're great servants, they are terrible masters. There have been some leap forwards with DeepMind teaches itself to walk, Facebook chatbots teaching themselves a new language, GANs, which is stands for Generative Adversarial Networks, creating deep fakes, images, and art without being trained through machine learning first, art that even fools even the most watchful human eyes, and of course, Adobe showing off its AI model's ability to recreate human voices by literally putting words in the former President Obama's mouth, creating entirely fake PSAs with a frightening real rendition of the former president's voice. These examples, of course, and many more seem like Skynet is just around the corner, with machines gearing up to take over. But as the video awkwardness shows, the machines are not quite ready to replace us. This event, known as singularity, is way off. And because of that, we as designers are now in a new era of design where we have an unprecedented opportunity to control the path that AI will go next. We're designing for man and machine together. And at IDEO, we call this design for augmented intelligence, or D for AI. One of our cultural values at IDEO is to be optimistic. And I, for one, am optimistic we'll find the right ethical path for AI. Before we get too much into the future, let us start by answering some basic questions about AI, its impact on human experience, why user experience design has some unique ethical challenges when it comes to AI, and real-world ways to address these challenges in pursuit of creating human-centered design. For us in user experience, the central question has become, how do we as designers augment the human experience with data and AI without losing our humanity? It may seem like a lofty, far-off question to answer, but it's not. And we as designers, researchers, and technologists are in a unique position to guide AI to a more human-centered future. Let's start with the basics. What exactly is artificial intelligence and how is it designed? AI is the ability of a computer-enabled program, machines or systems to transport information by learning and decision-making. Despite my early examples, today's world is dominated by what is called narrow AI or weak AI. Weak AI is artificial intelligence that exhibits intelligence, but only to do one main task. So even though Google's DeepMind algorithm taught itself to walk, it couldn't teach itself to do any other task such as talk because it wasn't modeled to. Most AI today, including Siri and Alexa, even self-driving cars, Google search engines, all of these seem pretty sophisticated, but they are really just examples of multiple weak AI programs working together. We're a long way away from sentient beings of Skynet. Because weak AI can't multitask, so to speak, it makes today's artificial intelligence wholly dependent upon human creators, and more importantly, human-supported training models. This also means today's AI has severe limitations that aren't always apparent. So just how is artificial intelligence created? Algorithms, the lifeblood of AI are algorithms. What's an algorithm? An algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. We, as humans, actually create algorithms every day, even without a computer. If you think about algorithms as just a set of if X then Y rules, then you'll know what I'm talking about. For example, let's say you watch the weatherman on news at night or check a weather.com app. And when you see rain in the forecast, you decide to put an umbrella in your bag. No rain detected, no umbrella. You've made a decision based upon a model you created. Weatherman says rain, umbrella goes in bag. Weatherman says no rain, no umbrella goes in bag. Algorithms are the building blocks of intelligent systems models, and they think much the same way. Put simply, an algorithm is a problem-solving process. Most algorithms that form the backbone of intelligent programming or AI are decision-making models that learn to return an outcome. You can say humans were the original algorithm model maker, and most of artificial intelligence is crafted to simulate human information processing. To get a deeper understanding, let's look at how we process information. If you're a student of HCI, this model looks eerily familiar. Human-computer interaction model developed by Peter Lindsay and this guy named Don Norman, whom I'm sure you know, and extended or revised by many others. This model displays cognitively how we process information. A stimulus, usually external, occurs. We perceive it with our senses, sight, touch, smell, etc. We search our short-term memory for interaction with similar stimuli in the past, and based upon our experience, we have some sort of external reaction or behavior. We wait for a responsive stimulus from the world to our reaction, and the process begins anew. We are training our brains to think. Applying this model to AI, data, large, ginormous sets of data from text to numbers to song playlists, are the external stimuli fed into an algorithm model that has been programmed with a set of rules to execute a task and produce an external result. The model is trained first, processing large amounts of data over time, searching its memory banks where it had been right or wrong so that it can return the correct result. Models are constantly fed stimuli and can get frighteningly accurate in a short amount of time. That's how powerful they've become. At IDEO, we like to describe intelligent systems in the terms of sense, act, and learn framework. By our definition, an intelligent system is any product, service, system, or even organizations that can sense and understand their context in some way, take action informed by what is sensed, learn what works, and adjust its actions accordingly to achieve a goal. Sound familiar? How is AI designed? AI systems are built through learning, massive amounts of learning. When you type in cat into a search engine, how does it return the right image? The answer is that someone had to make available to a program thousands of cat images so that it could recognize a cat and then thousands of a dog or a squirrel to see if it can tell the difference. The process would be tedious for us, but for programs, it's routine, and they can process massive amount of data to be fairly accurate. In fact, more accurate in some cases than humans. However, don't get depressed yet. Though AI systems are incredibly great at processing large amounts of information, they're not so great at picking up subtle nuances of the world of human behavior. That's why an AI system may beat the world's best Go player, but can't really tell a picture of pure static from a picture of a dog. What's important here is that the input we talked about earlier for any intelligent system starts with the human. AI systems do not function independently of humans. While some AI systems teach themselves new skills, such as how to walk, they have to be programmed to even seek out those new skills, which means AI systems are not infallible, and we, for now, have a modicum of control over these systems. In short, narrow AI starts and ends with people. Narrow AI is controlled, created, designed, and trained by people to interact with people through devices, social media platforms, vehicles, and robots, and a whole host of other services that hover data. So, no matter how automatic an AI product seems, its origin and original thought was first created, designed, or trained by a human. This is where user experience needs to come in. Algorithm builders can be computer engineers, computer scientists, but most likely a model's creator is a data scientist. But an algorithm can literally learn from or be trained by anyone. For example, each time you use AI-enabled services like Google's Map app or Waze or a search engine, you are training it. Because an AI in current use is because an AI in today's world are all currently generated by humans and are being created for mass consumption, this highly technical product has run a collision course with user experience. According to Gallup, 85% of Americans use at least one of 6 products with AI elements. 84% use navigation apps, 72% use streaming media services. Yet, unlike other technology products that are regulated by their use, such as electric cars, digital financial tools, or healthcare equipment such as MRIs, most AI products are let loose on people with little thought as to how they should be designed or human interaction. Well, I won't say little thought, but sometimes there isn't much thought. So technologists, computer scientists, data engineers, and computer engineers know a lot about data and AI. These developers of AI products may rarely study psychology, sociology, and cultural aspects of people who will be eventually interacting with the product by design. This has created a sort of ethical crisis when it comes to AI, especially in the social media platform and content realm. These are just different examples of AI in the real world. Chatbots, speech-to-text robots, Alexas, Cortinas, Google Assistants, image processing tools, and driverless cars. This is a picture of the flight recorder for the Ethiopian Airlines flight that crashed last month. The airline industry actually has been at the forefront of AI development. In fact, we at IDEO use different aspects of the industry as analogous experience for our AI designs. One concept we like to explore is agency, and especially agency when it comes to people who have to operate instruments who can think on their own. While past UX dealt solely with a one-sided agency framework, a person decides when and how to use a device. With AI, the agency framework becomes two-sided. Two sentient parties, each other with their own agenda, have to operate in the same context. This is where things can get tricky and even tragic. While the jury is still out on exactly the cause of the recent spate of tragic accidents concerning Boeing 737 MAX 8, there are disturbing signs that a lack of UX understanding may have contributed to pilot control issues. There was a clear case of agency being taken away from pilots, and there was a lack of transparency in that loss of agency. This isn't a technical miss. It seems more like a UX issue because the context is about the pilot's ability to give feedback to the system and vice versa. That's a distinctly human need that was taken away. It seems the current intersection of UX and AI occurs when a technical product is built and the UX designers and researchers come in to help make it user-friendly. That's an oversimplification, of course, but it gets to the point that the technical side and the user experience side are often separated. Just like in the nuclear power industry, but just like when the nuclear power industry ushered in a bunch of socialists flooding engineering rooms to create new design discipline called human factors, we're at a user experience crossroad that demands a better collaboration between developers, computer engineers, and now, of course, data scientists. Recent research shows that if you want to design ethical AI, the barrier between technical development and user experience has to go away. Recent research presented at EPIC and CHI and other conferences show when engineers, developers, designers, researchers, and data scientists do not have a shared understanding, a common language, or an integrated knowledge knowledge base, it makes it difficult to collaborate in a way that influences and empowers each other's disciplines and methodologies. It also makes it more difficult to align a design direction with shared values. This means that proximity is not enough. And it's my theory and my research is showing that even multidisciplinary teams sometimes might miss the mark. Instead, a transdisciplinary approach where information and learnings are transformative among disciplines yields better AI. If you want to know more about that area of research, I'll be producing a research paper about this soon, as well as presenting this organizational approach at a research conference in Toronto in June. And also through my short course, Mastering Design Anthropology for Better AI. So we've been through, so even though based in math and statistics, data-driven models are anything but impervious to bias, prejudice, and downright bad nature of humans. Whether these unethical values are passed on to the mathematical models by their creators or a function of their use or abuse, math with no point of view really doesn't exist in the world of big data. Because behind every data point, every binary expression, every formula, function, and statistical model are actual human beings. We've also learned that user experience research and design must be tightly coupled with AI modeling to ensure more ethical AI. What if your organization doesn't believe that? What if you're the only party? What if you only get to the party after the AI cake is made? There are still common issues to look for when designing for intelligent systems. Let's look at some of those. One of the biggest ethical challenges of AI is labor exploitation to create AI magic. What I mean by this is products are far from magic. In fact, people, a lot of them poor, are used to train AI models. So there's an entirely new low-skilled labor class that has been developed to make our artificial intelligence seem intelligent. This class is dedicated to training, moderating, and monitoring AI-fueled products. And for some, their foray into tech is affecting their health. From prison inmates in Finland who train AI classifiers for startups, to Kenyans from Kibera, the largest slum in Africa, who spend 8 hours a day creating training data for self-driving cars, to even social media human content moderators who have to snatch the video of a man committing suicide before he gets to your social media display. These so-called tech workers are a long way away from posh Silicon Valley. AI can sometimes have a negative effect, not only on the back end of its creation, but also out front when it interacts with people. Historically, we haven't been good at designing out the indelicate parts of our culture. So human bias seeping into AI outcomes shouldn't be a surprise. Just look at how we've used basic mathematical models in the past, such as the US Census. We use numbers gathered from the US Census to enact policy, distribute resource, and determine housing and medical subsidies. But because of racism, sexism, and other inhumane human tendencies, there are many groups who either went unfunded or were just left out altogether. Let's not even mention voting and the Electoral College. 3/5, anyone? And to this day, LGBTQ people aren't, and so far won't be, counted in the census. So if you don't get counted in the census, do you even exist? You certainly won't get resources. This is Catherine O'Neill. In 2008, she was a hedge fund quant mathematician and saw firsthand how really bad math could lead to financial disaster. She left the banking industry and became kind of like a crusader against bad mathematical models. She calls them weapons of mass destruction. And she was the one who kind of busted the myth that data was agnostic. With her popular blog, mathbabe.org, O'Neill emerged as an investigative journalist and wrote Weapons of Math Destruction to detail how opaque black box algorithms rely on biased historical data to do everything from sentence defendants to hiring workers. In Chicago, we have our own version of the Minority Report. It's called the Strategic Subject List, which sounds benign, but really it's an algorithm that predicts crime. This algorithm also predicts people who are most likely to commit violent crimes. This photo is Robert McDaniel, who was sitting on his couch one day when two cops showed up at his door on Chicago's West Side. They weren't there to arrest him. Instead, they said, "We're watching you." And unbeknownst to him, Robert, who had never been arrested and never been in trouble with the law, he was on this pre-crime list. Citing privacy concerns, the Chicago Police Department has refused in the past to release who's on this list and why, until journalists sued. And right now, there are about 400,000 people that are on this so-called heat list. Throughout its creation, this algorithm is actually kind of predetermining people as criminals, even though they haven't created a crime. And this is what O'Neill in her book called A Weapon of Mass Destruction, highlights what can happen when people put blind faith in AI systems. When AI isn't human-centered, when its impact isn't measured by the effect it has on people's lives, the potential for harm is enormous. Another ethical challenge with AI is the weaponization of it. Today, data systems and algorithms can be deployed at unprecedented speed, and unintended consequences will affect people with that same scale and speed. As UX designers, we have to look out for algorithms that could be weaponized against the people that are using them. And some of our cognitive biases are triggered during our interactions with AI-enabled media, products, or services that can affect really how we think as well as how we act. Tristan Harris is founder of the Center for Humane Technology and inspired the associated Time Well Spent movement. In 2008, Mark Zuckerberg, after the blow-up with the presidential campaign, embraced this time well spent, a phrase coined by Harris as a design goal for Facebook. And Tristan is one of the people who have been talking about this in a long time, that never before in history has such a small number of designers and such a non-diverse number of designers have such an influence on how billions of people think and how they decide to make choices. Tony Fadell is also one of the designers on what I call the Mea Culpa tour, really kind of regretting some of the design choices that they made for these products. And he says he just wakes up in bed, cold sweats every so often thinking, what did he bring into the world? And he started thinking this after he had a child who became almost indignant after the iPad was taken away from his child. And this, of course, is Mark Zuckerberg, and this is a photo that was done with a controversial cover from Wired magazine in March 2008. And the entire issue was about the Facebook presidential election and the filter bubble and Russians hacking their algorithm to weaponize it, basically. But what I want to point out here is that Youngmin Kim, a professor of journalism at University of Wisconsin-Madison, did extensive research on how Russians targeted ads were distributed on Facebook platform. And really, she just found one place, one agency that was able to wreak such havoc on through the algorithms. And that was because this is where it gets really crucial for user experience, because what they did really amplified a lot of the data-driven tools to trigger a lot of cognitive biases with people who interacted with this content. This is why UX and AI is so important. User experience for AI has to go beyond tasks. It's beyond usability because the technology is beyond function. It can be used and it can use. AI can be understood and it can understand. It can provide protection and it can also violate privacy. AI can decide and AI can act. UX for AI has to encompass more than behavior, what people are doing, buying, or what behavior they exhibit. Because of the scale, speed, and potential AI harm, AI UX must consider more deeply human needs, such as value, culture, agency, trust, confidence, privacy, even identity, freedom, the need for community and isolation, affection, protection, creation, understanding. This is the Max Neese model for human needs, and this is the one I like to use when I'm researching AI products. When you're designing an experience where a person's free will can be limited or even usurped. Example, a self-driving car preventing passengers from exiting a vehicle because the car spots a cyclist faster than the person. You have to design an experience that feels more like protection rather than denial of freedom. This is a key distinction in designing user experience for AI. AI design isn't just about how many miles a self-driving car can conquer. It also needs to be about detecting whether its passenger needs isolation or community in any given moment. Something a bad Uber driver can miss. The potential for harm is too great for AI not to be ethically designed. And we've already seen what happens when ethics gets missed. So how can we address some of these problems? And I think this is my go-to kind of illustration. You can find it in Wikipedia. It was done by John, I'm going to say this wrong, Manhugan. He did basically a visualization platform to map out more than 180 cognitive biases that are at play when humans make decisions. I'm understanding these biases is essential to understanding how humans interact with the world, but I'm convinced that there are a select few of these biases that can be most affected by interactions with AI-fueled products, such as self-driving cars, social network platforms, and law enforcement products and services. In July of 2017, Edward French, 71, was killed in San Francisco. One of the murder suspects was arrested 2 weeks before his death for gun possession and parole violation. The suspect was in court and was assessed and released based upon a public safety assessment score. It's a computer-generated score that helps calculate whether a suspect is flight risk or not. And even though people in the court, including the prosecutor and other law enforcement officials, said that the data seemed incorrect about the suspect, and later it was found that the data was incorrectly entered into the system, making the murder suspect seem less violent, no one questioned the public safety assessment score that was generated by the computer. The prosecutor and the judge, some said, knew of these aggravating circumstances about the subject, and that showed that he was high risk, and yet he was released anyway. This is a clear demonstration of automation bias. The tendency to depend excessively on automated systems to the point of overriding correct decisions by humans. This often can't be avoided in the design of AI. Humans just have that bias, but if you understand that it exists, you can build in what I call a kill switch, something that allows the human to override the automated decision. It's best to design internal checks and balances within the intelligence system so that it does its own policing. That takes a bit more sophistication than common algorithms. There's also a lack of checks and balances on decision making. The algorithm performed as expected, but bad data made it make the wrong decision. And so when you're designing these kind of automated decision-making models that people are using to make decisions about people's lives, there has to be some kind of reconciliation between human knowledge and machine knowledge. And later on, we'll get to some design principles that will help you coax that out. Humans have a propensity for acquiescence to technology. This has been shown in research over and over again. This idea that people don't trust AI, it's kind of like been debunked. The more that a machine does something right, the more that people will trust it. And so we have to understand this when we're designing these systems. As a designer, you just have to take into account these human biases. If you don't, there could be dire consequences. Better and faster and more efficient may not be the answer. In May 2016, Joshua Brown lost his life after his Tesla vehicle crashed into a semi-truck trailer. Brown had been engaged the Tesla autopilot feature, and the software didn't detect the white side of the trailer against the daytime sky. The car slammed into the truck at full speed, 74 miles an hour, and Brown was killed. But what really went wrong? Tesla was found innocent of wrongdoing in the crash, but let's look at its design. The more projects that I work on that involve AI, the more I realize that to design within the human experience, you have to learn a lot more about people. This goes beyond seeing what they do. but also motivating that also understanding the reasons and motivations that influence their behavior. And I know this seems like really big, but it's imperative that we understand in a more collective way why humans behave the way they do when it comes to designing for AI. This includes unconscious and conscious stimuli to our information processing tools, otherwise known as our brain. I studied psychology in college and find myself returning repeatedly to those lectures on subconscious when doing design research on AI. In HCI, you learn about heuristic bias pretty quickly, the idea that humans make assumptions about what they see in the world based upon past experience. And this lessens their cognitive load so that they can keep it moving. But another bias here is automation complacency. And this is probably what happened in Joshua's case. Automation complacency is what we see when it's the tendency to pay insufficient attention to or monitoring of automation output, usually because the output is reviewed as reliable. If you engage a self-driving car in the self-driving mode, then it's logical that you would think that the car could drive itself. But that's not what happened. You've probably seen the person who's in the car stand at a GPS navigation system to find out where she's going, but refuses to look out the window to see the destination that's right next to them. I've done that so many times. This may seem funny and absurd, but human psychology tells us that we're biased towards technology. And if you start combining these biases with AI, you can get some pretty interesting results. In 2017, Kim Nelson had moved back to her hometown in South Carolina. Her boxes were still scattered around her apartment while her two daughters played, and she was scrolling through the newspaper when she saw that refusal for vaccinations was up 70% in her hometown. It just struck her as weird why moms were rejecting vaccination at such a high rate. And she started talking to other moms in her small town, and she started noticing that one mom who had her two previous children vaccinated was actually waffling on the idea to get the third vaccinated. Despite no evidence of vaccination causing any lasting harm to her children, these women just refused to think that vaccination was good. How does something happen like this? Well, one woman vaccinated her two children, but the third child in this era, she's thinking maybe shouldn't get vaccinated. Anti-vax stories and Russian ads probably would have fallen flat without a real cognitive bias called availability cascade. Put succinctly, availability cascade is the tendency for humans to believe something solely because they see it repeated. The adage, repeat something long enough and it'll come true. Former Facebook engineer Antonio Garcia Martinez told Wired magazine in 2016 about the 2016 elections, I think there's a real question if democracy can survive Facebook and all the other Facebook-like platforms. Before Facebook, the argument used to be that you had a right to your own opinion. Now it's more like you have the right to your own reality. So there's a series of cognitive biases that come into play when media and content is constantly repeated in many different forms in the same way. And this could be done by bad actors with ads, but it can also be done by rapidly spreading content algorithms. Availability bias is one, also anchoring bias is another, confirmation bias, of course, and authority bias. If it's seen in some kind of news story, even if it's fake news, it may seem true. How does this happen, though? And one of the former engineers at Google thinks it has to do with model opacity and, of course, models amplification. A lot of these algorithm models that work at these sophisticated levels of social platforms like Google and YouTube and Facebook are really complicated. They're so complicated that a lot of people, even the engineers, are struggling trying to figure out how they work. And so the lack of transparency in AI model makes it very difficult to pinpoint why and when models go awry. And models are highly efficient and can often amplify the results, making it difficult to fix issues before they adversely affect a lot of people. And this is a common ethical challenge of AI. And Chaslot, he was a former YouTube algorithm engineer who noticed that his best friend's brother-in-law was spending a lot of time on YouTube looking at videos about the flat earth. There was an editorial by a New York Times writer called YouTube, the Great Radicalizer, that kind of detailed how when she was searching on YouTube during the presidential election, she kept getting autoplay videos that feature white supremacist rants and Holocaust denials and other disturbing content. A lot of people were getting autoplay videos from the likes of Alex Jones, Michael Savage, Mike Drudge, men only known to small groups of listeners existing on a diet of AM radio and infomercials, had suddenly become top of YouTube recommendation lists for soccer moms looking for information about the day's news. For Chaslot, he actually noticed it in his circle of friends. And when he found out that his best friend's relative was watching videos about the flat earth, he also discovered that there was a flat earth convention. And a lot of the attendees came there because they watch autoplay videos on YouTube. And so Chaslot wrote a whistleblowing Twitter stream about YouTube's algorithm, and he called it dangerous. He quit his job and started algorithmtransparency.org and basically started scraping Google's site to try to figure out how its algorithm was working. So now that we've gone full on into the harm that AI models can do, what can we do as designers to kind of spot some of these and stop them from being put out into the world? One of the things you want to look for on how to spot a weapons of mass destruction or AI model that may create vast harm is look at the intent use of the model. What is the model intended to do? Are you using an algorithm model to find a way to overcome food deserts in urban areas by predicting housing shifts? Or are you using the model to predict housing shifts so that you can avoid building in low-income areas? Often the intent of a model will point you into whether it's going to be destructive or not. Do you use proxies instead of actual measurable data? Are you substituting a fake data metric because you can't really measure the real thing? At a hospital medical school in England, they started an automatic application reviewer process. The computer basically started hacking out or rejecting applicants who used really bad grammatical English. But what happened was these applicants rejected were often medical students from places that where English is a second language. The computer used proxies such as gender, race, and foreign-sounding names to reject applicants instead of measuring applicants' actual capacity to speak English or perform medical procedures. This resulted in 60 out of 2,000 applicants being discriminated against and rejected because of race, gender, and country of origin. The path to AI harm is usually opacity, scale, and then damage. Other ways is the model scary, fast, and scalable? Can it be, can you hack the model and weaponize it? Is the model perpetuating human bias? And is the model unchanging? Did you set it and forget it? Or AI models need to be dynamic because they take in information all the time. If you set a model and you forget it, it has a propensity to kind of like it could go awry. And then how would you know? Some other model limitations, some other challenges or ways to spot WMDs includes the model is limited or isn't disclosed or taken into account in design. So model limitations are not known. Also, model outcomes are a little bit unpredictable and lead toward extreme. And model may exacerbate a human cognitive or social bias to the extreme. So now that we know all the problems that can occur and we can spot those, what exactly do we do about them in design? How can you tackle some of these? This is a quote from Michael Montanaro. I always get that wrong. And he's part of a growing group of design leaders who are pushing designers to push back on this technology overload that we're getting. Saying no and why more. And so this is leading us to a place of ethical design. Let's just start by defining ethics. We'll stick to applied ethics so we don't get into theoretical, and that is ethics developed for industries such as business, media, or medicine. This is rules people who have something in common, group, culture, organization, or industry, agree to act by. That's what we call applied ethics. There are definitions of what you should do and should not do as a member of this group. And inevitably, your road to ethics design for AI will begin with laws. The European Commission has enacted sweeping guidelines on data privacy, and two US senators just introduced a bipartisan bill to prevent large social media platforms from using dark patterns. But as designers, we have to go beyond the law. So is it legal? Isn't just where we start or stop. We as designers already have an ethical framework to draw upon, the definition of human-centered design. And I think the latter half of this definition, counter out possible adverse effects of use on human health and safety, is a great way to start a vision for how to develop a practical, ethical AI design. I used it as inspiration to create my own personal design ethics code and worked with human-centered designers at IDEO to develop our ethics principles around AI, which we've codified into ethics cards. This is my own personal one. I encourage you to create your own. And also encourage you to encourage other people in your community to do the same, as well as your organization. Some steps to do that is to answer some questions about what you value as a designer. Why do you have those values? What does those values look like in practice? And what design practices would violate those values that you have? And I'll just, because I'm short on time, I'll go into the data ethics and AI kind of principles that we developed at IDEO. One of our tenets, we have 4 tenets when it comes to AI and design. And the first is data is not truth. At IDEO, we've been thinking a lot about ethics and design. And as a design researcher, ethics is on my radar all the time. We recently acquired a new firm of 16 data scientists, and as we've been working together, we've been working on trying to develop a good framework for practicing human-centered AI. After many projects, talking to data scientists, researchers, and designers, and our clients, we came up with this code. And the first tenet is data is not truth. Data is created, generated, collected, captured, and extended by humans. Even raw data is never truly untainted. The fact that data set exists means a human has already decided to capture a signal, how to go about capturing it, and how to store it. That's why data is always incomplete and messy and needs to be interpreted and analyzed. It can be biased through what is included or excluded, how it's framed, and how it's presented. Just because AI can do something doesn't mean it should. Projects should be rooted in the deep understanding and respect of human needs. While artificial intelligence may be a viable component, it may not always be the most or only desirable solution. Respect privacy and the collective good. While there are policies and laws that shape government collection and use of data, we need to reach a higher standard than when we get sued. Learn deeply about individual and societal values in the context you're designing for, and look for where individual sensitivities about privacy overlap or conflict with community benefits. Unintended consequences of AI are opportunities for design. This is one of my favorite tenets. As with all design challenges, designing something won't always be right the first time. Use unexpected outcomes and newly discovered consequences as opportunities for iteration and improvement on models. Because we're a makey culture, we developed activities that you can do within your project teams to kind of further your human-centered AI design. These activities are centered around kind of practice principles that we have here at IDEO. And the first one is designing clear handoffs, clarifying each moment in a person's relationship in an intelligent systems, thinking about people behind the data, considering the system, mapping data and people, balancing giving and the give-get loop, anticipating mapping people and data, anticipating market pressures, takeovers, and hacks, listening for unintended consequences, capture only minimal valuable data so you don't need more, so you don't capture more than you need. And all of these, including the activities that you can do in your projects, are available for free on our Medium. Right now, they're in our Medium, on our Medium IDEO Stories link, Data, Ethics, and AI. We will be making these into cards that you can order. So hopefully we'll have that soon next month. And here's some AI ethics inspiration from around the world. Microsoft has a really robust website. It's called The Future Computed, and it talks about artificial intelligence in society. It also just released kind of 18 human-centered AI principles. I encourage you to look that up. IBM has this model of the Trusted FAIR model, the Trusted AI Network. It's a wonderful model that I really found inspiration from, and I also encourage you to look that up. So, in conclusion, ethics is knowing the difference between what you have the right to do and what you can do and what you have the right to do. And I hope that you are inspired as designers to know that you have a part in making sure that ethical AI is interacting with people. We're kind of like the last line of defense. And so it's our job to really help to shepherd our new AI products and services in a more human-centered way. And I'm done. I kind of like breezed through that. So, Carm, I'm not sure what happens now.
Yeah, you're right on time, Ovetta. We have about 8 more minutes. I didn't want to disturb you. So if anyone has questions, feel free to drop any questions either in the chat or in the questions box of the control panel. We do have one question, and the question is, isn't it also true that not interacting with AI can trigger certain biases that change the way we act?
Absolutely. I mean, that's why we study those biases, right? So the reason why I focus on triggering is because I think that a lot of people think that AI is agnostic. That just what happens in my newsfeed is just kind of something that pops up. Or what happens on my YouTube video is like something that pops up. But there are little design decisions that kind of reinforce some things, like the autoplay on the video, right? Or the recommendation engine. And that's why YouTube changed its algorithm, because it started noticing some of these signals about the algorithm going awry and people spending way too much time going down rabbit holes. And I'm not saying that people don't have personal responsibilities. The user always has personal responsibility. What we don't want is to design AI that exploits some of these cognitive biases that we have.
Okay. We do have a few more questions. This one just came in. If we make provisions for AI, autonomous decisions can be killed by humans at any point. So how can we decide which are these points?
Yeah, I think for the example in the Boeing example, pilots have been interacting with autonomous systems for years, a lot longer than most other users. But what has always been kind of like imbalance is the pilot's decision to override what's going on, because the pilot is taking in other information that maybe the plane is not. And in that case, pilots were having a hard time reversing the decision that the AI had made. And so when in research, we have, if you go to, I glossed over it, but one of our principles is designing clear handoffs. And this is about agency. And so in research, when we're researching designing intelligent systems, we pinpoint those agency moments where users and people decide that that's when they want to have control. And so we have a series of exercises that we do. We did this with autonomous vehicles. We did this with insurance, autonomous insurance, kind of like recommendation engines. There are places that you can, in research, figure out when we call it the timeline of agency. When the human thinks it does, when the human person thinks that he or she does it best, when the system may do it best, and when they do it better together. And it's really not about kill switching so much as it's about how does human provide feedback loop to the machine that it wants control, or that it doesn't know, or that the person wants control and that, or doesn't know what's going on, and how does the machine actually give feedback to the person that they have control and are making decisions?
Okay. We do have time for a few more. How do we train AI to combat malignant misuse for unknown unknowns?
Yeah, so this is really fun. There are a couple of AI researchers who are super smarter than me, but this is an area of research that I find really fascinating, is really training AI adversarial networks to fight AI. It's like training the AI to fight bad AI, right? And it sounds really weird, but it is a kind of like a vertical of research that some social justice places like Black Data Science, some other places, my friend Raphael, he's an interaction designer at IDEO.org, he's doing. Some of these social activist places are creating AI to kind of like detect bias in applications, right, in hiring. Creating AI to detect extreme news. I'm actually working here at IDEO on a white space project to create an AI to detect fake news. So there's this response from the technology community, just like any other hacker community or any other kind of community that sees bad going on with technology. There are these people who see technology can be created for good to combat those bad things that can go awry with an AI model.
Great. Of course, we're getting a lot of questions about resources, books, conferences, websites. Is it possible that you could share some of that with some of the attendees today, if you know any offhand? Otherwise, I could probably, connect with you offline and make sure we get some resources to our attendees.
Yeah, one of the things I wanted to do was a resource list of all the things. Like, I read all the books, so you didn't have to, but of all the different types of books that have informed our creation of our ethics principles. And Carm, if you could email me that, I will email you that list, because I didn't have it compiled or ready for today, so that you can share it. I was on the ethics panel. I was on the AI ethics panel just last week, and I got another list of great resources and stuff. And I also have organizations that you can go to. I know I just talked about IBM and Microsoft, but there are a whole host of organizations that you can that are doing some really interesting things, including data in government, transparency model.org. Like, there's a whole list of places that are doing interesting things in this realm. Excuse me. Sorry, I'm so sorry.
Nope, you're fine. Okay, this is great. So I can connect offline, and all of our attendees today, we'll make sure we send out when we send out the link to the recording, we'll make sure that we send out a link to those resources and materials. I think we're at time.
Okay.
I was going to try to squeeze in one more question, but I think we're at time. But thank you so much, Ovetta, for joining us today.
And I'm so sorry I went so fast, but I was trying to get so much stuff in there.
And I know that the attendees would like to have these slides made available as well. So I just want to make sure, we get the attendees as much reference and resource as possible. So thank you, everyone.
I just want to plug, I have a feedback short survey. So would love to hear your thoughts about the presentation.
No problem. So thanks again, Ovetta, and thank you to all of our attendees today. Again, be sure to register for the short course with Ovetta. It's the first. It kicks off the first Friday of May, May 3rd, and so there are 3 Fridays when Ovetta is going to go and do a deep dive into all of these topics. So be sure to check the UXPA website for that short course. Again, thanks everyone for attending, and thank you, Ovetta. And everyone have a great Friday afternoon.
Okay, you too.
All right, take care. Bye-bye.